what you are watching this because you either had Spanish MT or you weren't able to come today for some reason. So you are expected to watch this video and still get everything out of MT that I am hoping you to get out of it. The do now for MT would be this. So why did you sign up for AP Biology? And I wanted you guys to be honest about it. You might be wondering why we're starting MT off like this, and it's because we wanted you to get grounded in the desire to take this class. AP Biology is not a requirement for graduation or a requirement for DSST. If you were a junior, you could have taken regular biology. If you were a senior, you could have taken another senior level elective. So I wanted to know why AP Bio. Why are you here? You don't have to be here. Why are you here? So some of you, it might be the GPA boost. Some of you might really love science and want to study it in college. Some of you might hate science and want to do the exact opposite and avoid taking it in college. So if you take the AP test in May and pass it, that could get you college credit, which means you could avoid taking biology in college. Whatever the reason might be, just like think about that for a second. Why are you here? The reason why we're going over this is not a super happy one. So we're going over the case study formative because we noticed that there was a lack of integrity practiced on these case studies. So we're going to talk about the case study, we're going to talk about integrity, we're going to talk about the future of assessments and what this means for you guys. So first of all, a big apology to those of you who were honest on the case study and who worked your butt off and did the best that you could to submit your work. I apologize. This is not for you. Please keep watching it though, because I want you to understand a couple of things moving forward. This is mostly for those of you who took the easy way out. So if you were one of the students who took the easy way out and who got these answers online somewhere, I knew that the answers were out there. I knew that the answers were online. And so maybe it was my fault for being naive and putting so much faith in you guys when I know that it's easy to cheat. It's easy to look things up. And times are hard, times are stressful. So I need to be more careful about what I choose to give you guys in class, and I'll talk about that more in a second. But I just want to let you know what we're going to do about it. So first of all, we're not grading the formatives. We don't think that it's right to put those grades in. We don't want to penalize the people who worked really hard and did poorly, have them get bad grades at the same time that students who cheated are maybe getting good grades. So we are just not going to grade it at all. It's not going in IC. That means that the summative is going to be the only grade that you have for this unit that's going to be not like P&P. So it's going to be more weighted. So it's going to count more. Some other things that we're going to do, we are not going to have questions that you can find online. So that's me. I need to be more careful, make sure that you cannot find these things online. So I'm going to select and research questions so that they cannot be found. Or I am going to make them up myself. So that's going to be one thing that I do. They're also going to be open note assessments. If something that you worked on and you created is going to help you perform well, I want you to use that. Especially because these questions are going to be starting to be selected a little bit more carefully. You should be able to use these notes to remind yourself of things that you might have forgotten while still being able to demonstrate your ability and your skill set. That being said, no open internet. Hopefully this goes without saying, but based on the case study, it does not. No open internet. Open note, good to go. You made it, you created it, you worked hard on it, use it to be successful. And last but not least, assessments are going to be timed. And this timing is going to be pretty strict in an attempt to avoid something like what happened on, what day was that? Monday, from happening again in the future. So bringing us back to the do now. Why are you in AP Biology? I know that it doesn't look like what you were probably expecting it to look like. This is what it should look like here. These are pictures taken last year in AP Biology. It was fun. It was lively. People were always talking, always working together, always using their hands. And I loved it. I loved teaching it. The students loved coming to class. And I just know that it's not the same this year. And that's okay, but it's hard. I did not teach so that students could get good grades because of things that they're doing that don't even involve them learning or them working hard, if that makes sense. So I don't care what your grade is if you're not actually earning that grade based on what I've taught you, based on what you've worked to learn. Hopefully you didn't come to AP Biology just so that you could sit and not learn anything and then turn around and look stuff up online. That is not learning, and learning is a privilege. I know that that might not seem like a statement that you agree with right now, but think about all of the people who want to go to school and who can't. Like, you guys are still getting a really good education, and I still love my job, even though it looks a little bit different, and I still love teaching you, and I want you to learn. And if you're not learning, then there's more changes that we have to do. This isn't easy for any of us, so we're going to make these changes. I need you guys to advocate for yourselves, to reach out if you have questions, reach out if you need help. But the last thing that I want you to do is to get a good grade if it's not earned and if it's not based on knowledge that you've learned in class, or by extra work that you're doing outside of class, because it is AP. So that's my big speech. That's my spiel. This was why this MT was so important, because we need to do a reset and we need to ground ourselves in why we are here. We are here to learn. If you don't learn and you take the easy way out, then when you get to college, you're not going to know anything and you're going to fail. When you get to the AP test, you're not going to know anything and you're going to fail. And you're going to have wasted this time still putting in effort to get a good grade, but doing so in the completely wrong way. So hopefully this spoke to you a little bit. If not, let me know. I'll do what I can to get through to you. That's all I have for right now. That being said, because you may or may not have done the case study using your best effort and your knowledge, we are going to go over that as well. Because I do want you guys to understand how these processes work. You don't need to have any of these memorized, you just need to be able to interpret them. So I'm going to help you interpret these ones. So get out your copies if you haven't already, so that you can go through them with me. So the key thing here first to know is that both of these diagrams show the same process, they just show them in different ways. Your first job was to write an email answering all these questions. One of those questions was, what was the initial signal or the first messenger? That is the chemical that starts the whole thing. So remember that that thing has to bond somewhere, has to bind to a receptor. The easiest way to find this out for me was actually to find the response first. So when I went and found the response, I found it pretty easily. I'm like, oh, okay, well, the end of the road. The response is what the result is. So relaxation. I find where this is happening. It is happening in the smooth muscle cell, meaning that in order for this to happen in the smooth muscle cell, that signal, that ligand, that first messenger has to go into the smooth muscle cell. So I come over here and I'm like, what's coming into the cell? Oh, nitric oxide is coming in from here, and nitric oxide is coming in from here as well. Some other stuff is happening to make this nitric oxide, but it's the nitric oxide that comes into the cell and starts the process. So it's the nitric oxide that is my first messenger, or my ligand, or my signal, whatever I want to call it. And my relaxation is the response. Some people got this confused with a lack of erection, but actually these processes are the normal processes that lead to erection. The relaxation leads to erection because when that smooth muscle cell gets relaxed, blood can flow into that region. So that is one of the misinterpretations I did see from those students who did practice integrity. anyways, we have the initial signal, we have the relaxation. The second messenger is probably one of the hardest parts of this. You might not be able to tell, or maybe you didn't know like how to do this, but notice how the nitric oxide, it doesn't point directly to the GC, meaning it doesn't turn into GC. It doesn't help lead to GC. It combines with GC. GC and nitric oxide together come down to make this. And this little dash here that I see in between NO and GC, that means that the NO and the GC are bound together. The NO is the ligand. It binds to GC. GC is the receptor. So the receptor is intracellular, which was another part of the question. And I know that because the nitric oxide, which is my ligand, combines with the GC to make this complex that's both of those things together, meaning they're bound. So the arrows might not have made that very intuitive, but the fact that it's NO dash the GC means that they're bound together. So if I know that the NO is the ligand and it binds to this, this must be the receptor. So this is reception. This is not my second messenger yet. The second messenger is the first thing that is activated after that reception. So if I keep following this, I have GTP turning into cGMP. That's the very first thing that gets made as a result of reception. So this must be my second messenger that goes on and activates everything else. So the cGMP is actually the second messenger. Cool, cool. Moving on to the next part. All right. So in this question, you had to talk about ginseng, Viagra, and then if those two things, if neither of those things worked, then what could be broken? So basically, it tells you that ginseng enhances erection. And then it asks, so then what do you expect it to do to the nitric oxide? Well, I'm going to remind myself of what the goal is, what the response is. The response is relaxation. So if I get relaxation, I get an erection because blood flows in. So if ginseng enhances this, that means this whole entire process is enhanced. Nitric oxide is my ligand. So if I'm thinking like, okay, if the nitric oxide leads to erection and somehow ginseng enhances the erection, that means that if I'm going to take a guess on what it does to the actual ligand, I would guess that it enhances it or increases it. Because if I increase the ligand, I increase the response. So that is a safe assumption to make. Same thing about the Viagra. The question specifically related to Viagra, again, to enhanced erection, so enhanced relaxation. And it asked about this molecule here, the PDE5. So again, if I'm enhancing the relaxation, I'm enhancing this whole process. So I'm going to work backward here. Okay, relaxation came from MLC, which came from the MLC PTase, which came from PKG, which comes from cGMP. So if I'm working forward now, the nitric oxide bound to the receptor, activated this second messenger, and then my second messenger went on to do two things. It made the PKG, which went on to do this and cause relaxation, but it also made some of this. So if I am enhancing this, then cGMP must be increased as well. I have a lot more cGMP, or it's more active, meaning it's going to make more PKG to go on to do this, but that also means it's going to make more PDE5. So it would make more PDE5. I only have a minute left to do the last question. Okay, so if neither of these work, then that must mean something else is broken. So one of these things that leads to relaxation, if I know that cGMP should be increasing, we just said that. We know that the nitric oxide is increasing, we just said that. So maybe when cGMP goes on to make this PKG, maybe the PKG doesn't work. Or maybe there's no MLC PTase. Maybe the PKG can't use that to turn into MLC. Maybe the MLC doesn't work. So it's something upstream or further along in the process than the parts that those chemicals actually affect. Okay, I did it. I made it. We're still proud of you guys. Know that we're Yeah, we're so proud of you. We just want to make sure you're learning and want you to reflect on why you're here because we want you to be here and we want you to learn. And you guys are awesome. And have a good day.